Welcome back. This is chapter 1-2. This is recording number 1. All right, so we're going to talk about 1-2 now. That's the variables and types of data. So we're going to define what a variable is, and then we're going to talk about the different types of variables that there might be. We just finished 1-1, and that's where we just kind of had an overview of what do we mean by descriptive and what do we mean by inferential statistics. So let's jump right in here to the this concept of variables and types of data. Okay, and we refresh our memories here that we gain information about a particular situation. We collect data for random variables. Okay, we're going to go into detail now about what kind of variables are there and what kinds or types of data is there. Okay, so the first thing we do is we classify variables. So remember, variables is an attribute or a characteristic. As an example, how tall is this kid? As an example, how hot is it today? Okay, those are variables. Okay, now those are just examples. A qualitative, we can classify it two different ways, qualitative or quantitative. Qualitative are variables that have categories according to some characteristic or attribute. So for example, gender, male or female. Your zodiac sign, are you Gemini or are you Taurus? Are you registered as a Republican, as a Peace and Freedom, as a Democratic Party, whatever, okay? So those are qualitative variables. Those are categories. Okay. Another example, other examples of qualitative variables would be religious preference. Maybe where do you live? You're a California native, you're an Iowa native, whatever it happens to be. Okay, quantitative, there's going to be some numbers floating around there somewhere. Okay, a quantitative variable are variables that can be counted or can be measured. It's numerical in nature. Numerical in nature. Whereas qualitative is categorical. You put it into categories, not by numbers. I mean, if I were to say, well, what's the number value for being a Republican? It doesn't make any sense, right? Okay, so qualitative is categories, quantitative is numerical. Some numbers are floating around somehow, some way. And here's the example that he gives, talking about age as an example. Okay, all right. So now, when we're talking about quantitative variables, quantitative involves the numbers. We further classify them into two groups. We say they're either discrete or continuous. So let's look down here. This kind of helps us. The variables can be either qualitative, and that's the end of it, or it can be quantitative. If it's quantitative, it can be further classified as either discrete or as continuous. So what's the difference? Discrete assume values. In other words, they take on values that can be counted. Okay, so these are things that can be counted, like 0, 1, 2, 3, 4, 5. How many kids are in a family? How many students are in a classroom? How many calls are received? Okay, that sort of thing. Those are called discrete variables. On the other hand, continuous variables, you can't count them exactly. It is a continuous variable. So like temperature, you can be at 90 degrees, you can be at 90.1 degrees, you can be at 90.2 degrees, 90.3 degrees. Whatever value you pick, you can have an infinite number of values between any two specific values you pick. So that's the definition right here. So let's say you have a temperature of 90 degrees and a temperature of 91 degrees. How many values can you have between 90 and 91? You have an infinite number. It can be 90.1, it can be 90.2, 90.3, but each one of those can be further divided. Between 90.2 and 90.3, you could have 90.21, 90.22, 90.23, etc., etc. Okay, so I hope you get the idea. So here's some examples here. I think these are pretty self-explanatory. Again, I'm not going to read all of these to you, but I'll help you with one or two and then leave it up to you to read them, okay? Okay, so the number of hours that kids watch TV, well, that's continuous, right? Because, yeah, it's 1 hour, 2 hours, 3 hours, but it also could be 1.3 hours, 1.4 hours, 1.5 hours. So that's continuous. Touchdowns, well, touchdowns, I don't know how many points they are, but the number of touchdowns is certainly discrete. You don't have 1.5 touchdowns. Okay, so I'll let you read those over, okay? oftentimes the language we use is we'll say that continuous data is measured, continuous data is measured. On the other hand, we say that discrete data is counted. So that's kind of a big clue when you're reading a problem. Okay, so here he is. He's talking about the various. I'm sorry. Give me 1 second. Okay, so this section here, these sentences here, are kind of dull as dishwater, but they're important. Okay, so bear with me on this. Okay, and this is kind of real life situation too. When we're talking about continuous data, they must be measured. So the answers will oftentimes, maybe virtually all the times, they will have to be rounded off. They'll have to be rounded, okay? In theory, the temperature is a continuous variable, right? But if I said the temperature today is 91 degrees, and then you said, well, can you be more precise? Yeah, I can be more precise. It's 91.5 degrees. Well, can you be even more precise? Well, yeah, I can be more precise. It's 91.56 degrees. And you just keep on going, depending upon your instrument, right? Well, that gets to be tedious, right? And that gets to be ridiculous. So what we normally do is we round off because of the limits of the measuring device. And normally we round off to the nearest given unit. So heights might be rounded to the nearest inch, weights to the nearest ounce, and so forth. So if you say that, okay, little Johnny here is 73 inches tall, okay, well, is he really 73 inches, or is he 73 inches and a little bit more? Or is he a little bit less than 73 inches? We rounded it off. So how do we do it normally? Normally what we do, the convention is that we say, well, if you give me an answer of 73 degrees, what that really means is, I understand that to mean, is any actual measurement from 72.5 inches up to, but not including, 73.5 inches. That's just a convention. We don't include the upper guy, the 73.5. We don't include that as a possibility. If you did measure Johnny as being 73.5, you would round it up. You would say, well, we're going to report it as 74 inches, okay? So what do we say? We say that the boundary of this measure is given as 72.5-73.5. But the concept is that we don't include 73.5. The boundary of a number then is defined as a class in which a data value would be placed before the data value was rounded. So what is it? Where does it really go in this class or in this set? Okay. Now we write it as for convenience like this, but it's understood to mean all values up to and including 73.5. We do not include 73.5. If it happened that you really measured it at 73.5, you kick it up to the next class is the concept. Okay, so that's what he's saying here. I'll let you read that, okay? And then here's a table for some examples here, okay? I hope that's pretty clear. Do you work your way through those? You see the examples. Give me 1 second here. Okay, so now I'm going to make it worth your while that you're watching these videos, okay? I follow the book very closely, so sometimes people say, geez, why don't I just read the book? Why do I have to listen to this crazy old man lecture? Well, here's an example. I hope I'm going to add some value to this, and make your time worthwhile. Do you see what's going on here? Let's skip the first one here. Let's skip this one. 23 degrees Fahrenheit. The class boundary is going to be 22.5 up to 23.5. What you do is you take 1/2 of this unit right here. The significant digit here is ones, right? It's 23. So you take half of the ones, that's 0.5. So you go down 0.5 and you go up 0.5. So you go down to 22.5 and you go up to 23.5. You see how that is right there? Same thing here. 154.62, well, the significant digit here is tenths and then hundredths. So you go you do half of that last significant digit of the tenths, okay? So it would be 5 tenths. Excuse me, 1 second here, 1 second. Okay, sorry, I may have misspoke there. So the 6 here, that's tenths, right? This is hundredths. This is thousandths. So all right, so you're right here at 6/10, 2/100ths. Okay, so these are tenths, these are hundredths. Okay, you go up or down, or you go up and down 5 units of the next significant digit. So it's 62. You go down to 61.5. I'm sorry. You're at 0.62. You go down to 0.615. How far down have you gone? You've gone down 5 thousandths. Okay, you're at 154.62. How far up do you go? You go up to 154.625. You go up 5 thousandths. It's tenths, hundredths, and thousandths. I think if you draw it on a number line, it probably makes a lot more sense. Okay, so this one, the B and the C are real simple, and everything's we're happy, right? This one, there's a typographical error, unfortunately. Okay. So there's a typographical error here in the electronic version, and there's a typographical error in the book version, at least my edition, the paper copy I have, and they're two different errors, okay? So it makes you totally crazy, all right? But that's just life. That's just human affairs. There's going to be errors. Okay, so it's 17.6. What should be the boundaries? Well, the boundary should be 17.55, so that's right here, and it should be, let me start over again. So 17.6, that's what we're reporting. I'm reporting this as being, I measured this to be 17.6 inches. So it is assumed that the boundaries, the class boundaries, is you go to the left and you go to the right. You go a little bit less and a little bit right to get your boundary. So just like up here, we were at 1.6, that's what we reported. We went to the left to 1.55, and we went to the right 1.65. We go a little tiny bit to the left, a little bit to the right. So what this should be here should be 17.55, and then that's to the left, so that part's correct. To the right, it should be 17.65, not 18.55. Where the hell did that come from? That doesn't even make any sense, okay? So this is just totally wrong here in the electronic version. Sadly, in the paper version, it's also wrong for this one, but it's wrong in a different way. In the paper version, at least in my edition, it's 16.55 dash 17.55. So again, just kind of totally wrong, okay? So I'm sorry about that. That's just the way it is. So if you have your book, if you have the paper version, what you should do is cross out that answer and write in your book the way I did, 17.55 dash 17.65. That's the correct answer. Okay, took a while, but I finally got through that. Okay, all right. Okay, so I'm going to go ahead and end the video here. Right, this is a good point to end it, because we're going to now go into how they are categorized, counted, or measured. So that's going to be a slightly different concept. So we're going to end it up here, finishing with this concept of discrete or continuous values, and then this idea of the boundaries. This boundaries makes you crazy, but if you do a few of them, you'll see what I'm talking about. It's not as hard as it looks. Okay, you just go up and you go down a little bit. How far you go, what that little bit is, depends upon what units you're using. If you're using 23, that's like a whole number. You go up and you go down 0.5. If you're here at 0.62, you go up and you go down 0.005. Up and down 0.005. Okay, so it's always that last digit. You take half of that last significant digit and you go up and you go down half of that last significant digit. That's it. That's the rule. It's not that hard. Okay, I'm going to go ahead and end this video.